iDS Talks is a podcast dedicated to helping corporations and law firms find new and effective ways to leverage data, giving them a decisive advantage both in and out of the courtroom.
Hello, and welcome to another edition of iDS Talks. My name is Jonathan Sachs, Chief Revenue Officer at iDS, and I'm joined today by Jacques Nack, iDS's Chief Innovation Officer. We're here today to talk about feeding the beast. What are you really giving AI? Jacques, welcome to the podcast. So, Jacques, I thought this was going to be, I think this is going to be a really enjoyable podcast. It seems like AI is everywhere. Everyone is talking about it. It shows up in my reels. It's something that even my dad, one of our podcast listeners, talks to me about. So I figure we have a lot of folks out there who are also talking about it and want to really get an understanding about this topic of feeding the beast that is AI, whether it's them feeding it or other people feeding it. And so I figured we'll just jump right in.
Well, feeding the beast, that's actually quite interesting expression talking about AI. I think from an engineering standpoint, it takes us elsewhere. But what do we really mean when we think about feeding the beast? We're not, I don't know if you've ever really wondered what powers artificial intelligence, right? It's not the wires, it's not the code, but what's the main thing that makes AI stick? So today we want to talk about, these concepts of feeding the beast. And we're talking about, well, the beast in the machine itself. So if you picture AI as this gigantic, ever hungry creature, a beast that grows smarter and smarter and creative and more useful each time it eats. Well, the food that it eats, that's not pizza, that's not pasta. The food that it eats is data. It's the words, it's the sounds, videos, everything in between. The bites, how fast you walk, and every time you upload a picture, every time you post a blog, share a review, an opinion, every time a teenager has a comment somewhere online, it goes into the beast. And what the beast does is that it gobbles it up. And it's not just one machine. Like we want to think about AI as being this one machine, one place that does one thing. But in fact, it is a collective intelligence of many, many machines, all trained to do very specific things that are all over and around us. And they go in and they collect and gobble up that stuff, right? And so AI learn by example. He learned because he studies billions and billions of sentences of interactions that we have with the web, with our phones, with our cars. And it grows stronger because it's able to better answer those questions and write our stories and make us laugh, right? You've heard about the ChatGPT jokes. I don't think you have. So this beast is never satisfied. It's never satisfied. So
Yeah.
it continues to learn. The language evolves. It gets better at mimicking us. It gets better understanding. It rewires what it might have learned even just a year ago. So that's sort of what that is.
Yeah, so I really appreciate that, Jacques, right? And I think you're right. The idea of it being a beast is not just something getting stronger. I mean, this is almost like stronger, faster, smarter. It's just making it a more advanced being. Um, and the other thing that you said that I think is really important for people to understand is it's everything that we're doing, whether it's you're consciously thinking about I'm doing this and the AI is going to learn from it So being consciously aware of that versus I'm just doing what I normally do, and it just so happens that it's making AI smarter, faster, better, all of that. Um, so that leads to the next question, Jacques, which is then understanding that we're giving this so much. Let's just stick with the feeding notion. We're feeding it so much. Why does data quality matter when it comes to AI? And what happens if you feed it bad or poor quality information?
So there's two topic here in this question. First is this idea of precision. Um, we are building when we build AI, you're building something that sometimes is generating answers in life or death situation. You're building something that often is providing critical answers to decision makers. So the precision of the AI requires the best data, right? So you basically have the world's best engineers right now. It's the one of the most advanced field and one of the newest, you know, revolution that we're witnessing. And the most advanced technology, we're talking about the most advanced computer chips, the most advanced systems that are built to reach the stars to augment a human being so they can do better. So, what if you're building this really fast machine? It could be a car if you like cars, it can be a rocket ship. But what if you're building this very fast machine and you just put junk fuel in it,
That's
right?
bad. That's
So
bad news. That any
it's
car
bad
guy,
news.
any car girl, car woman, car guy, car person is going to sit there and say that's bad news.
Right. So that's exactly what it is. So AI at its core is a learning engine. It's a learning machine. It just grabs what you bring in. It does not assess what you're feeding it and say, I'm gonna grab this and I'm
Mm,
not gonna grab that. It has a model that will get this data and try to make the best out of it. The thing is, if the data is flawed, and so before I go to the result data, one thing I like to say is the computation that are run by all these algorithmic systems and models are are running to do a couple things. Sometimes they run and they give you a causal answer. So if the result of the final computation, and other times it would infer the answer. And there is a real cost when we're doing one option versus the other, right? So we know, for instance, that an inference as of 2024 data cost about 1 teraflop of computing power. And a definite answer costs about 6 teraflop of computing power. And so when we design this system and we feed it data, it gobbles the data, processes the data, but a lot of the time when we produce the answer back to the user for energy savings, for power saving reasons, we may infer the answer because it's most likely the most logical one. And so when you train your system with bad data, well, I'll just tell you what it gets: garbage in, garbage out, right?
right.
You create a system that has bias and discrimination. You create a system that has inaccurate predictions. You create a loss of reputation for people that are using your system. You create, when it's analyzing and looking at financial data or operational costs, it may just give you the wrong results, right? At the end of the day, a lot of the answers we get from an AI pipeline are inferences. They are predictions. They are not necessarily the actual truth. And for that reason, we need to train these systems with the best possible data. There are real consequences if we do not.
Makes sense. And it seems like that time worn adage, garbage in, garbage out, equally applies here. So that's good. But let me ask you this then. So we understand now you want to put good data in to the systems, accurate information, cleaner data, cleaner information. What should companies be thinking about with respect to privacy? And this is two-parter with respect to privacy, but also to IP. Because I remember, Jacques, back when AI was really starting in the news, and there was a major technology company that somebody asked ChatGPT to check their code, and now your company code is out there for out in the world, no longer under your control. Um, Hopefully people are a little more sophisticated now, but from your perspective, what should companies think about with respect to privacy and IP when training AI?
Well, let's take that one company. I don't know, Gizmo Inc.
Sure.
Let's
Good.
imagine that this company is building the next great breakthrough in artificial intelligence. So they've got the talent, they've got the vision. This is what this thing is going to do. They've got the technology, but here's the catch, right? It's a big one. When they are using data to train their AI, it's not just numbers, right? It's a lifeblood that we pour into this system. It's the lifeblood of the creativity of those people who have built the systems, the people that have fed data into the system, and so forth. So why does privacy matter? So let's talk about that. AI model often learn from large, let's call them oceans of data, and some of that is very personal. It may be um, it may be information about someone's health. It may be some about some trade secrets about whatever it finds out there. And companies that aren't careful, well, they risk exposing this private information, and while doing that, violate privacy laws and lose public trust, right? Privacy is this very funny thing that we all feel is inherently that we inherently possess. It's ours, information about ourselves, where we move, and how, and so forth. But I said once, and I'm going to say it again, we don't really pay attention to privacy until misuse of our private privacy rights impacts our property rights. And
Ah,
that's a lot of what we're trying to see, right? When all of a sudden your property rights get entangled with your privacy right, but not to your benefit, where something is used against you to deprive you of justice, to deprive you of a right, a benefit, etc. And when you take these personal data at a massive scale and you put in a very large system that million may access, while you're exposing it at a scale that is completely irreversible. And so it's very important to consider privacy when designing the systems, how to maintain data within specific boundaries, and how to do that. And there's a number of ways that the companies, so there's privacy by design, there's data minimization, only using the data you absolutely need to use. There is a anonymization technique. If you really have to work with data that really integrates a lot of personal information about people, well, you can use anonymization and pseudonymization, which are ways to remove what will make the data identifiable. There is getting clear consent. Some people are okay telling you and letting you use some of their data, so you have to make sure you have the thing to do that. And continues to look at what the output is from your process, what the law says. There's been quite a shift in privacy law around the world from the initial publication of the OECD human rights in 1948. Now, as recently as last year, no, 2 years ago now, even Texas enacted privacy rights. So we have to look into that.
so understanding all of that, Jacques, how can a business innovate with AI while still staying ethical and secure, making sure that they're protecting their privacy of people and IP.
Well, the path forward is one where we are augmenting our knowledge workers with the output of an AI process. I think it's at this point inevitable to think that we will actually live in a world that doesn't use AI. So every business is today facing this question: how do we harness artificial intelligence to innovate while staying ahead of the values, keeping our data safe, keeping our customers happy, and our reputation safe, right? So the foundation of business, um, uh, um, the foundation of this, another business, the foundation of this theory. I mean, when it comes to AI development, there's almost churches, I would say, and there's a lot of people who advocate, and I'm one of them. We advocate for ethical AI. So ethics should be, for most business, their first competitive advantage. Is to recognize that ethics aren't just about, it's not just a checkbox. It's not just something that you do, but it's something that has to be woven into the thinking and the process and what we build. It means more than just avoiding disaster. It means building something with the intention of transparency, fairness, and that people would use. That's the first thing. The second thing is to integrate that in your process from day one, right? You have diverse team, you have bias mitigation, you have a human-centric design. There's a concept that was taught in mathematical school and computer design schools. I think, I don't know if they still do it, but 20, 25 years ago. And we're talking about the improvement in human-computer interactions and how we wanted to be able to enter information into this digital world without necessarily using the physical boundaries of a keyboard, right? And how do we design better computers to make this experience more pleasant? AI is one path to augment that, right? So it's something that will go beyond augmenting what we have here, but also how we integrate and how we integrate our digital world with our physical world, right? And just using those two sentences, it takes me straight back to Pramaj Mistry and his talk a while ago about doing that, something that led into different conversation. The second thing about modern ethic is how do you build transparency and accountability? You want to be able to have an explainable AI. What does my AI do? How does it go about extracting this information? And what models does it use? What model does it understand? How can you audit what it did, right? You want to have clear governance about what the AI is able to do. So in very, very large systems, systems that are used by millions and millions of people, hundreds of thousands of companies, you want to have an ethics board because you can't just trust the output of it and think that it's good to go. And so you have to have also an honest policy of disclosure when when people are interacting with AI, that they know that the voice they are speaking to is not a real customer service person. The person who wrote the algorithm is not a real human being, and so forth. Um, and then the last piece, which is very important in developing AI in an organization, is this we talked about it already, is the notion of privacy and the notion of security. It's non-negotiable, right? You have to design a system that protects the data. You have to design a system with zero trust. You have to design a system that complies with the regulation and all of the things we have out there. And finally, it's just about continuing to build and grow that system in a responsible way over time. That's how companies will integrate AI into their operation, into the business, into everything. Yeah,
That's
I can
some
keep talking about that.
Yeah, no, it's really some great insight, Jacques.
Yeah.
So let me end us with this last question, which is, which is the what's next. What's next for how we feed AI, especially with what's now real-time learning and even synthetic data.
Real-time learning, synthetic data have always been around, right? I think in the 70s, we didn't have the tools to run computing pipeline at the scale that we can today with the progress we've made in technology. And um, data augmentation techniques, creating and so forth, have always been around. I mean, a very simple data augmentation technique back in statistics school is you have a collection or you have a distribution with X number of things, and it's not enough to really calculate the mean, average, or meaningful output. Well, you take the data and you copy it 4 or 5 times, scramble the numbers, and guess what? You have more data that looks the same, and for the purpose of your exercise, it'll be about the same. So but the thing is, even though those techniques have been there for a while, the old ways or data as we use it back in the day is no longer relevant, right? For years, we trained AI on massive troves of historical data. We thought about snapshots. We thought about the searches, the magazine that were published in the papers for a while. But the the AI that's trained on yesterday's data is always going to be a step behind because human experience as it is something that actually is so fascinating and moves so quickly, right? So you talked about real-time learning, and this is kind of very, very interesting. Um, Learning methods available just a decade ago for most systems was supervised process or a non-supervised process. But now we have self-supervised process and we have self-learning systems. Well, what happens when we actually take that and we apply them to streaming data? When we are looking at the fact that AI is able to consume live stream of information that are happening in real time and ingest them through retrieval augmented process and return augmented answers from that, right? There's dynamic learning that includes instead of just looking at static model, we're seeing that AI is now continuously updating itself, personalizing preferences for a user. You can see that within your own interaction with one ChatGPT prompt or Perplexity prompt and other things like that. And then we also have edge computing, by processing data where it is created, exactly where it's generated, and on device, on cars, at your house, in your machine that is there collecting data, we are able to pull data in faster. So it's just a new frontier, which is real-time learning. The synthetic data revolution is because it is said that we are running low, running out on new data to train our systems. Basically, the bulk of the stuff that we are producing every day are not creating any new iteration or versions or branches of what the AI has already consumed.
Ooh,
And so
fascinating. Yeah.
and so now how do we actually address that? How do we continue to add precision into this system? Well, we have to fill the gaps, right? We have to figure out scenarios that have not necessarily happened. For instance, an AI feeding on news may not read enough about post-apocalyptic, survival scenarios. And so we have to think about that. Well, what if all 100 and all 40 uh, nuclear heads that are out around the world were detonated at the same time, but just to one place, and what comes out of it? So we are trying to create that, and we're also trying to get more precision in areas of privacy and compliance. It helps company innovate without expecting sensible or exposing sensible or regulatory information. So creating synthetic data allows us to do better with privacy and compliance when we are ingesting data in those domains. And it also help us in areas like bias and diversity to be able to generate balanced, diverse example that will kind of bring the conversation or the learning of a system right in the center. So instead of being fed data coming only from one side, we can also come with data that balances the opinion in somewhere else.
Wow.
I think the future is a blend of real-time learning and synthetic. It's been there, but the new real-time learning, the new synthetic options are not the same we were doing even 10 years ago, 20 years ago, or 30 years ago.
Yeah.
Yeah.
Well, Jacques, really great conversation. Thank you so much for joining me today. I'd also like to thank our regular subscribers, those that also may be first-time listeners, for spending time with us. If you'd like to learn more about iDS or want to subscribe to our iDS Talks podcast, you can visit idsinc.com or go wherever you normally get your podcasts from. If you're watching this on our YouTube channel, hit the like and subscribe buttons, please. Thank you again for joining us. I look forward to talking to you more about data on our next edition of iDS Talks.